is Yasin Aboud, class number 54, and today I'm going to be talking about artificial intelligence and what actually are we talking about when we speak of AI. The conversation around artificial intelligence has reached a fever pitch, driven by an absolute explosion in new technologies like chatbots and large language models. Yet, the fundamental terms AI, machine learning, deep learning, and generative AI are often used interchangeably, creating confusion. This tech provides a clear, structured explanation of how these powerful technologies relate to one each other. A framework for understanding the domain of intelligence. The relationship between those fields is best understood as a series of nested domains, where each is a specialized subset of the one before it. We will explore this landscape layer by layer. It begins with an aspiration, artificial intelligence. AI is the broadest field, encompassing any attempt to simulate something that would match or exceed human intelligence in a computer. The goal is to replicate the ability to learn, infer, and reason. This is not a new idea. The foundational work in AI began decades ago, when early research in the 1980s using programming languages like LISP and Prolog to build expert systems. A breakthrough in approach, machine learning. Machine learning is a subset of AI. Instead of being explicitly programmed with rules, the machine learns for itself by observing vast amounts of data and identifying patterns. Imagine teaching a machine to recognize a sequence by showing it enough examples of a pattern. For example, square, circle, square, circle. It can confidently predict the next item. The more training data it receives, the better its prediction becomes. The power of prediction and anomaly detection. Key capability 1. Prediction. Machine learning algorithms excel at looking at historical data and predicting future outcomes, from market trends to equipment failure. Key capability 2. Finding outliers. Machine learning is exceptionally useful for spotting anomalies, things that break the established pattern. This is critical in fields like cybersecurity, where an outlier might represent a user behaving in an unusual or unauthorized way. The engine behind the learning, deep learning. Core definition. Deep learning is a specialized type of machine learning that uses structures called neural networks to mimic the way the human brain operates. What makes it deep? The term deeps refers to the fact that these networks have multiple layers. This layered structure allows them to process information with increasing complexity and abstraction. Nonce. Much like the human brain, the output of a deep neural network can be unpredictable due to complexity of its layers. It can be difficult to decompose precisely why it reached a specific conclusion. The creative frontier, generative AI, core definition. The most recent and impactful advancements in AI fall under the umbrella of generative AI. As the name suggests, these models are capable of generating entirely new content. Underlying technology foundation models. This revolution is powered by a new architecture called foundation models. A prime example is the large language model (LLM), which forms the basis for modern chatbots. Beyond autocomplete, how LLMs generate content. Analogy. Think of the autocomplete feature when you're typing. It predicts the next word based on what you've just written. For example, the quick brown fox jumps over. An exponential leap. Large language models operate on a similar principle but represent an exponential leap in capability. They don't just predict the next word, they predict the next sentence, next paragraph, or even the entire document. They module the patterns and relationships with language at an immense scale. Is it truly generative or just recombination? The skeptics' view. Some argue that generative AI doesn't create anything new, but simply regurgitates and reassembles existing information it was trained on. A musical analogy. Consider music. Every note has already been invented. In that sense, every new song is just a recombination of existing notes. Yet, we would never say that new music doesn't exist. Composers still create original works from the same fundamental building blocks. In a similar way, generative AI uses training data as the building blocks to generate genuinely new content and ideas. The application, the applications and implications of generated content. Foundation models can be trained on more than just text. They can generate many different forms of content, each with its own set of possibilities. Text models, LLMs, power, power chatbots summarize existing content and generate reports. Audio and video models can create deepfakes by recreating a person's voice or likeness. This has positive uses in entertainment or for accessibly or for accessibility, for example, restoring a lost voice, but also carries a significant risk of misuse. Foundation models have fundamentally changed the adoption curve. Phase 1, the long beginning. In the early days, AI adoption was slow for most. It was a technology that always seemed 5 to 10 years ago, 5 to 10 years away. Phase 2, steady acceleration. With the arrival of machine learning and deep learning, uptake began to accelerate as practical applications emerged. Phase 3, vertical takeoff. The arrival of foundation models and generative AI caused the adoption curve to go straight to the moon. This is the technology that has propelled AI into mainstream use everywhere. The complete picture, a unified view of artificial intelligence. From the broad aspiration of AI to the revolutionary power of generative AI, each field builds upon the last. Understanding this structure is key to navigate the future and reaping benefits of this transformative technology. This was Yasin Loy Abboud, class number 54. Thank you for listening.